Lab 6. In this lab we are going to implement fork, a system call we will write in C. The writing of C language and compiling of this code is same as we have discussed in lab 5. We can write code in gedit text editor, or we can compile our code in GCC compilers. Fork system call is used for creating a new process which is called child process, which runs concurrently with the process that makes the fork call. After a new child process is created, both processes will execute the next instruction following the fork system call. A child process uses the same PC program counter, same CPU registers, same open files which used in the parent process. It takes no parameter and returns an integer value. Below are different values returned by fork. If it returns a negative value, it means creation of a child process was unsuccessful. If it returns a zero value, it means the newly created child process. If it returns a positive value, it means return to parent or caller. The value contains process ID of newly created child process. Parent, like we have a main method, int main fork, and then we have pchild int main fork method. We run these on operating systems. Here is an example of a fork system call used in C programming language. We are using three fork system calls and then printing hello. The number of time hello is printed is equal to the number of processes created. Total number of processes is equal to 2 raised to power n, which is 8 in this case, where n is the number of fork system calls. So here n is equal to 3, it means 2 raised to power 3 is equal to 8. So there are total 8 processes, new child processes, and one original process, that is L1. If we want to represent the relationship between the processes as a tree hierarchy, it would be the uh, same like this. Next program, predict the output of the following programs. We have a fork call. If fork is equal to 0, it means hello from child. If the value is not 0, it means hello from parent. In this code, a child process is created. Fork returns 0 in the child process and positive integer in the parent process. Here two outputs are possible because the parent process and child process are running concurrently. So we don't know whether the operating system will first give control to the parent process or the child process. Parent processes and child processes are running the same program, but it does not mean they are identical. OS allocates different data and states for these two processes, and the control flow of these processes can be different. The fork system call creates a new process. The new process created by fork is a copy of the current process except for the returned value. The exec system call replaces the current process with the new program.